Welcome, and thank you for joining us to celebrate 100 years of Emhart Glass, the pioneer of automation in the glass industry. When I joined Emhart Glass in 2006, I knew almost nothing about our history. I was then so excited when I learned how this company was started by some entrepreneurs, developed into a global leader of the industry, and changed glassmaking forever. So this is why we made this film.
Until the late 19th century, glass in America and Europe was still made manually by skilled glassblowers. Conditions in glass factories were harsh and unpleasant, and child labor was used for unskilled tasks. However, glassblowing was difficult to automate, so glassmaking was one of the last manual trades to be industrialized. Some semi-automatic machines were developed, but the dream of fully automatic glass container production remained out of reach until the 20th century. Our story begins in 1880 in Hartford, Connecticut. Two inventors, William Honus and William Lawrence, formed a partnership to design and build industrial machinery. One of their first projects was a machine to make paper bags. They soon moved on to glassmaking equipment. In 1912, they formed the Hartford Fairmont Company with a mission to develop automated bottle-making machines. Hartford Fairmont would become a pioneer of automation in the glass container industry and eventually take on the name Emhart Glass. Honus and Lawrence were not the first inventors to take on the challenge of automated glassmaking. The first automated bottle-making machine had been invented in 1903 by self-taught genius Michael Owens. The Owens machine worked by sucking up molten glass into a huge rotating set of molds. It worked fairly well, and it ended the use of child labor in glass factories. However, it was cumbersome and expensive, and it still needed an operator to remove the finished wares. Food company Beechnut used an Owens machine, but were frustrated with the quality of the jars it produced. They asked Honus and Lawrence to build them something better. To create their own machine, the young inventors needed a better way to feed molten glass into molds. Inspiration comes from the most unlikely sources. One night, new recruit Carl E. Pyler was spooning honey for a bedtime snack when he noticed how the honey formed into lumps, or gobs, as it fell. Could glass be made to do the same thing? A wooden prototype was soon built, but perfecting the idea took months of painstaking work. Working by trial and error, Pyler varied glass temperature, gob weight, and other factors, filling notebook after notebook with records of his experiments. Eventually, he perfected the paddle gob feeder, which used gravity to form gobs of glass that fell neatly into molds. Just 1 year after its formation, Hartford Fairmont had achieved its first major milestone. Incredibly, the basic design of Pyler's feeder remains fundamentally unchanged. Feeders working on the same principles are still in use today, 100 years after Pyler's brainwave. Fitted with the new feeder, Hartford's press machine produced the first ever automatically manufactured glass jars for Beechnut. Hartford's machines were slower than Owens's, but far cheaper to buy and run. Soon orders were flooding in from factory owners, and foreign patent rights were quickly snapped up. In 1922, Hartford merged with the Empire Machine Company, another designer of glass-making machines, becoming Hartford Empire. 2 years later, Hartford Empire made the single most important breakthrough of its history, the invention of the IS machine by Henry W. Ingle. IS, or individual section, used multiple modules to form glasswares with the blow and blow process. It was fast, reliable, and flexible, and operators could work on one section without stopping production. And the quality of the finished product was excellent. IS was soon in use throughout the US and beyond, becoming the most widely used glass forming process in the world. Like Pilar's feeder, IS stood the test of time. The same technology is still used in almost every glass container factory around the world. The first IS machines had 4 sections and could make around 36 bottles per minute. In the decades that followed, their descendants came to feature up to 12 sections, each forming up to 4 glass gobs at a time, making up to 800 containers per minute. Keen to understand the problems faced by glass manufacturers at first hand, Hartford Empire built its own experimental glass factory, chemical lab, and optical testing lab. The tradition of understanding customers' needs has continued right up to the present day. During the 1920s, Hartford Fairmont expanded its expertise into new areas of the glass container production line. One of these was refractories, the heat-resistant containers in which glass is melted before being formed. As well as being supremely hard-wearing, refractories also need to ensure that the glass is evenly heated. In 1926, the firm teamed up with Corning Glass Works to form Corhart Refractories, a joint venture to design, engineer, and manufacture refractory systems. The enterprise was successful for many years before being eventually abandoned in the 1960s. Emhart's own refractory range took a major step forward in 1980, when President Ray DeVita oversaw the purchase of refractory specialists Laclede Christie, based in Owensville, Missouri. The company could trace its roots back to 1844, when it was founded as the Laclede Firebrick Manufacturing Company. Since focusing exclusively on glass refractories in 1976, Laclede Christie had built up an enviable reputation within the glass industry, and Owensville had been developed to include both a research laboratory and a manufacturing plant. In 1983, all of Emhart's refractory manufacturing was consolidated at the Owensville facility. As part of Emhart, Owensville continues to research and develop the glass industry's widest range of expandable compositions for glass refractories, with in-house expertise enhanced with technical support from the nearby University of Missouri. The end of Prohibition in 1933 provided a huge boost for the glass container industry, as demand for drink bottles soared. Hartford Empire's glass-forming technology was so successful and so widely used that the government began an antitrust action against the company in 1938. The proceedings and trial dragged on for 8 years. Finally, Hartford Empire had to allow other machine builders to license the IS technology. This changed the landscape of the industry forever. Now, for the first time, Hartford Empire had real competitors. By the 1940s, Hartford Empire had become a respected innovator, with a rapidly developing export business. At that time, the firm's directors realized that depending on glass could be dangerous, so they began acquiring other firms, beginning with Standard Knapp and Henry & Wright. This laid the foundations for the mighty industrial group that Emhart would later become. Before World War II, finished glassware was checked by hand. It was expensive and slow. The 1940s saw the dawn of a new era in the glass industry, with the first move toward automatic inspection. Hartford Empire launched the first automated inspection unit in 1945 and made inspection a key research priority from then on. Meanwhile, in Elmira, New York, enterprising young engineer Whitney Bud Powers founded Powers Manufacturing, which went on to become the leading innovator in glass container inspection. Emhart acquired Powers Manufacturing in 1982, allowing its customers to use the same firm for both glass forming and container inspection solutions. and work with a partner who truly understood every stage of their production process. Soon after the Powers deal, Emhart launched its total inspection technology, which automatically detected faults in finished glassware. In 2007, the inspection business grew once again with the acquisition of ICS Inex, based in Clearwater, Florida. 2 years later, the first fruit of the alliance appeared: Emhart Glass's revolutionary FlexInspect system. In 1951, Hartford Empire decided that the rapidly expanding group needed a new name. Its managers struggled to think of one until someone suggested using the company's cable address. It was simply Hartford Empire, abbreviated and in reverse, Emhart. The Emhart manufacturing group continued to grow by acquisition. By the 1950s, it offered a wide range of industrial machinery, as well as glassmaking machines, from seawater distillers to Skyworker overhead platforms. 1952 saw an important addition to the family with the acquisition of veteran Swedish machinery maker Sundsvalls Verkstäder, which had originally been founded as a bell-making factory in 1756. In time, the Swedish branch became the key site for building Emhart's IS machines, a role it still plays today. The Swedish acquisitions had an important strategic background. By the 1950s, the American glass industry was maturing fast. For Emhart, growth meant expanding its horizons to a whole new world of opportunity: Europe. Luckily, the firm had a new recruit who was perfectly suited to developing its European business.
In 1952, I came from Switzerland with some background in glass container manufacture and the objective to learn about the technological and industrial development of the glass container industry in the United States. In Europe, at that time, due to World War II, industrial progress and investments had been limited. At that time, I was 23 and joined Emhart Glass as an industrial trainee. It was a friendly, welcoming company, the technological leader, responding to my interests. In 1957, at the request of the president, Mr. Sixten Volmar, I transferred to Europe and opened up an office for Emhart Glass in Zurich, Switzerland.
During the years that followed, several European sales and service centers were also set up across Europe, and a new training center was established at Sundsvall in Sweden. Thousands of customers came here to learn more about IS technology. In 1964, Emhart Manufacturing Group merged with the American Hardware Corporation. The combined group, which took the name Emhart Corporation, had more than 25 divisions and employed 11,000 people around the world. 12 years later, in 1976, Emhart Corporation sealed another major deal, merging with USM to form the new Emhart Corporation. The combined business was a billion-dollar company with interests in many different industries. As the 1970s began, IS technology continued to evolve with the invention of the automatic gob distributor, which allowed for more and more sections to be added to IS machines. The 1970s also saw the first moves toward electronic control systems. Some of the controls developed in this period are still in use today. Building on its success, Emhart opened a new manufacturing facility in Windsor, Connecticut, and set up sales offices in Japan, Singapore, and China. By 1977, over 1,000 IS machines had been built at Sundsvall. But Emhart was not content to rest on its laurels and developed Advanced IS, or AIS, which consolidated all the innovative features developed since the creation of the original IS system.
When I first became president, I felt it was time for us to upgrade our product line and make it a lot more modern. And so in order to do this, we doubled our R&D investment and spent a lot of effort in computer controls and servo mechanisms. We introduced a lot of new products during that period of time. Plastic containers in about the mid-1980s dominated the rigid container business in the United States, which affected our business, obviously. And we decided at that point in time it was time for us also to restructure our manufacturing operations. And so we transferred all machinery assembly and production to Sweden. And we transferred all parts manufacturing to our very efficient Årbro factory. That left the United States with pretty much the job to assemble electronic components and circuit boards, and also to be the warehouse for the U.S. marketplace.
As a result of Ray DeVita's research drive, Emhart introduced Vertiflow, developed at Emhart's UK branch, which cooled down glass molds far more efficiently. Before this innovation, mold cooling was one of the least efficient operations in the glass forming process. Vertiflow almost doubled production speed, as well as enhancing the quality and strength of the final product. It saved energy, reduced noise, and increased the lifetimes of glass container molds. The 1980s also saw increasing use of electronics to control the production process, beginning a line of innovations that continues to this day. Electronics made IS production much easier to manage and more responsive to changes in demand.
At the end of my presidency, it was time to pick a successor. And it was clear that the center of our business was no longer the United States, but it was Europe. And so we decided to set up the group headquarters in Zurich, and we made Mike Cornaz the new president of Glass Machinery.
In 1987, I was honored to become the president of Emhart's Glass Machinery division. I was the first European president of the company. Having spent 30 years in various management positions of the company, contributing to the development and consolidation of our markets in Europe and the Far East, I saw my role as a commitment to maintain the strong relationships with our global family and the industry we served.
In 1989, Emhart Manufacturing Group was acquired by Black & Decker. The Glass Machinery division took on its present name, Emhart Glass. Throughout the 1990s, Emhart Glass continued to deliver improvements that made a real difference to its clients. The average speed of IS lines jumped by 10%, and inspection became even more precise and comprehensive.
I was happily managing one of SIG's larger international divisions when Ray DeVita and Mike Corner approached me. Then we had many discussions, but I felt home, not only because of the two, but also because this company was an American company.
In 1998, Emhart Glass found a natural home when it became an independent division within Bucher Group, the veteran Swiss machine maker. As a new century dawned, a new technology was born. The next generation IS, or NIS machine. NIS was a traditional IS machine at heart, but used servo-electric rather than pneumatic mechanisms. It was faster, more flexible, and more economical, and brightly colored too.
So we saw that the classical machine was kind of at their limit, and then we thought, why don't we go back to white paper, develop something unique, new, numerical control, servo-electric, and it has to be more effective, cheaper, etc., etc. It was a long development thing. It was hard, but I had a super supporter by Steve Pinkerton, who was engaged in it. At the beginning, we were lonely, the few who believed in it. Later, everybody developed it. It came the question of the coloring. We wanted to do something unique, and my wife said she saw these cows in Zurich. They were painted some of them by Andy Luzzi, and I asked him to paint the machine. Oh, I don't know whether nowadays they sell more the painting or more the machine.
A few years later, Emhart Glass launched FlexIS, the first fully integrated control system. As Kurt Siegenthaler neared retirement, the company began the search for a successor. It soon focused on Martin Jetter, the founder of Jetter AG, Emhart Glass's partner for the design and manufacture of electronic control systems since 2002.
When I was asked to become president, I felt proud. But I also had a lot of respect for this job and for the responsibility that comes with it, to lead Emhart Glass into the future. My target is to build on the achievements of the past by developing new growth strategies for our future. Therefore, we are now focusing on new technologies and products and on expansion into the emerging markets.
One of Martin Jetter's first initiatives as president was to open a brand new research center in Windsor, Connecticut. In the 1950s, Emhart had unlocked the next stage of its growth by expanding into Europe. As the 21st century dawned, the firm looked eastwards once again, identifying new opportunities in Asia. In 2009, an all-new facility was opened at Johor Bahru in Malaysia. 2 years later, Emhart Glass announced a major joint venture with Sanjin, one of the leading glass machinery makers in China. It is 2012. Emhart Glass celebrates a century of innovation in glass container manufacturing. From humble beginnings, the firm has become the world's leading international supplier of equipment, controls, and parts to the glass container industry.
We learned from our history that Emhart Glass was started and successfully developed by a group of people who had a desire to serve the glass industry and to find solutions for their challenges. Without their passion, the glass industry would not have developed as it did. The challenges might be different today, but the motivation for our work is still the same: to support the glass industry and to assist them in their efforts to achieve a better world where glass is preferred ecological packaging material, whatever the future brings. Our motivation and passion will always be to support our customers in their quest for sustainable profitability, quality, and increased market share through our automation solutions.
Emhart Glass is a truly global, multicultural enterprise with a worldwide network of branches serving clients of every type on every continent. But the journey is far from over. The company remains totally committed to innovation. Every day, its engineers are working tirelessly to find the next step forward, the next improvement to the glass-making process.